The cosine law. The cosine law. It's a tool used to solve triangles. What does it mean to solve a triangle? It means to say what all the sides are and what all the angles are. So this is just another tool to solve triangles. There's a triangle, and it doesn't have to be a right angle triangle. And what we learn is that the cosine law is a little journey that goes across this triangle. For example, a squared equals b squared plus c squared minus 2bc cos a. Look at this. A squared equals b squared plus c squared minus 2bc cos a. It's a little journey across the triangle that starts at a side and ends across the triangle at that angle. A squared equals b squared plus c squared minus 2bc cos a. Or we could say b squared equals a squared plus c squared. So we could start our journey here. B squared equals a squared plus c squared minus 2ac cos b. And again, we've gone across the triangle. Thirdly, we could start our journey at c and go across the triangle there. C squared equals a squared plus b squared minus 2ab cos c. C squared equals a squared plus b squared minus 2ab cos c. So it doesn't matter what the letters are. All it matters is that you take this journey and learn this little pattern. Not so much a journey as it is a pattern, but it starts at a side and it ends across the triangle at a vertex. Consider this. If we took a squared equals b squared plus c squared minus 2bc cos a and wrote it right down here, then we could take minus 2bc cos a, drag it across that equal sign to the left, take a squared, drag it across that equal sign to the right, and we'd have this, algebraically speaking, because subtraction would become positive and positive would become subtraction. And then we could divide both sides by 2bc and we'd arrive here algebraically. And this gives us another form of the same statement which originated up here. Now it looks like cos a equals b squared plus c squared minus a squared over 2bc, like this. And this is a useful form of the cosine law because we can use this to directly achieve an angle at a vertex. Cos a equals b squared plus c squared minus a squared over 2bc. Look at the pattern. A is over here with a minus sign on it. B and C are both up here and down here. Start with, we could go cos B equals a squared plus c squared minus b squared over 2ac. It's the same pattern. We could go cos C equals a squared plus b squared minus c squared. It's the same pattern. There it is again. So if you're capable of learning these simple patterns, then this cosine law becomes yours. It gets into your nervous system, and you too can use it. When would you use this cosine law? Well, there are certain times when it's appropriate. One of them is here. If we know an angle and the two sides that enclose that angle. In other words, it's contained by these two sides that we know. So we have two sides and an angle in between them. We use the cos law for that. Also, if we know three sides and no angles at all, we use the cos law. We seem to have lots of tools. Let's check them. Triangle trigonometry. We have SOHCAHTOA for right angle triangles. We have the cos law for these two particular instances in front of you here now. The sine law is for all the other cases. SOHCAHTOA is for right angle triangles. Cosine law is for these two instances. Let's do an example. Here's an example of cos law usage. We can see that the angle that we know is contained between two sides that we know. Angle contained between two sides, we can get the opposite side p by going p squared equals 34 squared plus 25 squared minus 2 times 34 times 25 cosine 116. It's the pattern. Use a calculator, come to this, and take the square root. That simple. And finally, let's take example 2. Find all the angles in this triangle here. Let's find all the angles. We have three sides, so it's one of those Cosine Law usage situations. One more note about this. Whenever you're using the Cosine Law to find an angle, always choose the largest angle. And remember, the largest angle will be opposite the largest side. That's why we'll start by finding angle C in this circumstance. We can start with angle C, and we can start by going cos C using the pattern equals 26 squared plus 21 squared minus 42 squared all over 26, 2 times 26 times 21. This pattern. Again, that's cos C equals 26 squared plus 21 squared minus 42 squared over 2 times 26 times 21. Like that. Work it out on a calculator, and I notice that the cosine seems to be negative. That tells me, according to the cast rule, that C itself must be obtuse. We also know that if we want an angle, we have to use inverse. So let's use inverse now. Angle C is the inverse. And we have, using our calculator, angle C is the inverse cosine of negative 0.5925. And we have angle C. Continuing, because we want to find the angles. So far, we've determined that angle C is 126.3 degrees. We did that here. Now, next we could get angle B. We never have to use the Cosine Law twice in a given triangle, so now we've used it once for this triangle. We can now use the Sine Law. Here we go. Sine B over 21 equals sine 126.3 over 42. That's a Sine Law. 21 multiplies over. Use your calculator. If you want an angle, use inverse. So angle B is the inverse sine of 0.4030, and the calculator says that. Don't take my word for it. Actually do it. And we can finally get the third angle by saying angle A is 180 degrees with 2 bites taken out of it. 180 minus 23.8 minus that 126.3, and we have our angle A.